Hey guys, my name's Ryan Green. I am the Western Regional Sales Manager for Shark Energy Systems. We are a unique company in which we take wastewater and put it to use for opportunities for high efficiency air conditioning and cooling, as well as low carbon heating. So after this, hopefully one of the things that'll be clear is, why wastewater in the first place, what kind of municipal support has been kind of gaining around different areas, some small scale opportunities that have already gone in, as well as some large scale opportunities that have gone in. And really, I'll sum it up with an idea concept that I've got of what I think the future American suburbs really could look like. So first off, what is the value of wastewater? We know there's a lot of it. We know it's virtually limitless, but really, what is a numerical, quantitative value for it? Turns out, U.S. Department of Energy estimated that over 350 billion kilowatt hours are discarded down the drains in the U.S. on an annual basis. So it's a whole lot of energy that's going down the drain. Putting into perspective, that's about 88 Hoover Dams worth of energy going down the drain every single year. So that quickly frames the argument of why are we looking at wastewater in the first place? It's virtually limitless. We've got an almost endless supply of it flowing beneath our city streets already. When we're taking energy from that thermal source, we're able to provide heating as well as hot water. And then when we're rejecting energy into that thermal source, we're able to provide cooling and air conditioning for buildings. Because we're not burning fossil fuels or anything like that, we're dramatically reducing GHG emissions around the board. And then all the equipment that ties into a wastewater heat recovery system is generally powered by electricity. So when we talk about the electrification and net zero movement and those types of things, wastewater heat recovery can really play a very large role in helping municipalities and even individual business owners achieve their electrification and net zero goals in a cost-effective manner. And then on the utility side of things, it can bring in a lot of ways to reduce demand. So when we go to this type of equipment, the overall electricity consumption in kilowatt hours reduces. But more importantly, on the utility side, their kilowatt demand in their summer peak cooling can also see a large dramatic reduction, which really helps frame the argument of future peaker plants and battery power, and helps fit those things into the right place. So I'm up in Denver, and our local municipal water or wastewater company is Metro Wastewater. And they have been on board with the concept of wastewater heat recovery for about 2 years now, actually about 3 years now, since the beginning of some modeling for a large project. And since then, they've got a live website and downloadable documents really just coming out and saying, hey, we support this idea. If you're within our service region, please give us a call because we're going to provide you a feasibility analysis, kind of showing where our wastewater lines are, rough flows, rough heat available, to see what we can do for your development. So they've really got on board with this as a way to align with the city of Denver's 80 by 50 GHG emission reduction goals. And it's really allowing the city and the area to attract developers that have eco-conscious clientele, a different type of clientele come to the area because of these types of developments. So, and then really when they studied it, just the heat available in the wastewater alone was enough to heat the cities of Arvada and Thornton in Colorado combined. So it's a tremendous amount of energy again that we have available, and there's groups out there that are really unlocking that opportunity. Secondly, also up in King County, Washington, they've actually taken it a step further, and recently in September 15th actually passed legislation that is an ordinance that relates to the sale of that energy in their wastewater line. So now anybody that they've got 3 pilot projects coming up, and those groups that connect to it are then billed at a $0.005 per ton rate. So for every, all the energy that they're either transferring to or from that wastewater line, that wastewater utility then is able to not only monitor that, but also then open up a new revenue stream that can become, increase revenues overall for that utility. Something else that we're seeing across the nation is so in January, leading engineering firms across the nation put out an open letter to the industry saying, MEP equipment manufacturers, this is what we want to see you guys produce so that we can help our clients achieve net zero in electrification. And the word that was repeated over and over and over throughout it were heat pumps, heat pumps, heat pumps. Some that particularly caught the wastewater heat recovery industry's attention were water-to-water domestic water heaters. So something that's going to take a water source and take energy from that and then produce potable domestic hot water in an energy efficient manner. And then secondly was simultaneous cooling heating machines. So what this is basically a heat pump that allows not only heating, but also simultaneous cooling at the same time. So the cooling effect, you get a byproduct of basically free heat. So you're able to get your hot water and chilled water production at the same time. So when you're able to use these types of sources, you're getting much more efficient transition to electrification. So this is something that the engineers have kind of been pushing for. So as I kind of push forward here, some may not know what is a heat pump. So this is kind of an education lesson. I've talked frequently about ground source heat pumps in the past. So one of the big things about heat pumps is, what are they? So basically in the engineering world, there's the second law of thermodynamics. And what that says is that you've got your heat or energy cannot on its own pass from a colder region to a hotter region. So when your friend's sitting there saying, hey, you're letting the cold in, they're wrong, the heat is going out. So that's the only way that it can transfer that way, unless you add work, which in this case in a heat pump is electric energy. Now, what if I told you they're actually all around us? And you've probably already used a couple of them this morning. Your refrigerator and your refrigerated air. So your refrigerator works by taking the heat, it may not seem like a lot, but the heat energy coming off your food, transferring that to a refrigerant loop, and then to the back or underside of your refrigerator. Hence why those areas of refrigerator orders a little bit warmer than the other, because that's that transfer of energy from inside to out. And then your air conditioner is, really the same thing. It's taking energy warmer energy from inside your house and transferring that outdoors via an outdoor condenser, or that fan unit that you hear bang on, bang off.
It's a nice visual, I think, for the average consumer to really
Yes.
keep in mind that, this isn't like mind-blowing technology, right? It's just, moving one set of air to another. But this is a nice little, I hope, if anything, people remember this visual.
So you've got different kinds of heat pumps. There are air source heat pumps where you're transferring energy, like Shelby came and said, is from one indoor source to the outdoor source. So it really depends on whether you're in heating cooling mode, whether you're rejecting heat outside or taking heat from the outside. Really, when you're breaking that down there, what that looks like is you've got your outside air interacting with the refrigerant loop, interacting with your inside air. So in heating, your refrigerant's absorbing the heat from the outside air and rejecting it to the inside. And then in cooling, you're just reversing that cycle and absorbing heat from the airstream indoors and rejecting it to the outside. You've also got what are known as water source heat pumps. So the big difference here is, instead of having an outdoor condenser, you've got a water loop that is then carrying that energy to or from the heat pump unit. So again, on the simplest side of things, you've got a water loop that's transferring refrigerant to air in heating mode, and then in cooling mode, you've got the opposite, where the refrigerant's absorbing heat from that airstream from the water. There are also water-to-water heat pumps, which is really no different than your water-to-air, except you're transferring heat energy to and from what I call a process water loop, which is like for radiant floors, radiant cooling, snow melt, those types of applications that you'd see in the HVAC world. So circling back to wastewater heat recovery. So what we'd see on a wastewater heat recovery heat pump is you've got raw wastewater transferring to refrigerant loop, transferring to hot water loop. So as that refrigerant will absorb heat from the raw wastewater, and then that heat gets rejected to another coil that creates your domestic hot water for your building. So that's how we're able to really, close that endless loop of just dumping energy down the drain on a building by building basis, and capture that energy from the wastewater and then transfer that into an all electric and super highly efficient domestic hot water source.
It's a good little reminder, flushing down our energy down the tubes.
Yep, quite literally. So some of the smaller scale opportunities that we've seen out there, one was a hotel laundry retrofit in Banff, Canada. It was they were kind of a remote location, so natural gas was never really an option for them. So we see that a lot in different mountain towns, or Santa Fe, those types of areas. So here they were using propane, so they saved a tremendous amount of propane and also had dramatic reductions in their utility costs. But the big thing here is for any type of laundry where we're just rejecting heat into an existing trough and then collecting that, the opportunity to pick that energy back up and then put it back into that laundry process is very large, and really creates a good opportunity for very super high efficiency heating, because that source water that we're taking, that source wastewater, is a warmer temperature. Another project was in Boulder, Colorado. It was about 37 unit multifamily apartment complex. It'll be commissioned later here at the end of the year. It is 100% net zero, does have a full photovoltaic system that coats the roof.
Nice.
All the wastewater energy is captured from the building. The Piranha or the wastewater heat recovery heat pump captures about 90% of that domestic hot water, or not captures it, but provides 90% of that domestic hot water for the building. And then there's an electric resistance water heater that provides that kind of top up. So no matter what, year round, they're anticipating a coefficient of performance of about 3.6. So putting that into perspective, 3.6 is actually about 360% energy efficient. So some would ask, how do you get 360% energy efficient? And that's because for every 1 unit of electricity we're getting out we're putting out 3.6 units of heat energy to that domestic hot water loop. So our device is making the energy coming in more efficient through the heat pump refrigeration process. So that's how we're getting more efficient. So when you're looking at electric resistance, you've got a COP of about 1. Or if you're looking at even your best natural gas condensing water heater or furnace, you're looking at a COP of about 0.95. So the efficiency gain you're getting by going with this type of system is huge.
Yeah, so this slide, Ryan, for anyone in El Paso that's a builder, works with builders, wants to be a builder, this is it. This is the future. It's not next year, it's now. It's actually been going on. So I really hope that if anyone in El Paso that's related to the real estate or building industry, this can be done, it's being done, and this is a really good example, Ryan.
Thank you. And really the next slide just hits it home for the developers that are kind of pursuing that net zero design. So one thing that you'll find, so even though this is in Boulder, the heating loads or the cooling loads are obviously relatively small, but even the heating loads are smaller because of the construction of a net zero building. Because these buildings are so much better built, have a lot less heat loss to them. They require less on the space heating and cooling. So what really becomes the driver of your energy load is the domestic hot water system. So that becomes very important, because on a multifamily that may be 3-4 stories tall, you don't have infinite roof space to achieve that net zero. So the goal is to have the lowest energy consumption possible, so that you have to can get as close to net zero given the roof space you've got. So when they were doing this, they ran an energy analysis, and versus the 3 different options they could do for creating domestic hot water electrically, and versus electric resistance, there's about a 32% reduction in the site energy use intensity, which is basically the energy use over divided by the square foot over the entire year. So that building became significantly more energy efficient over that time period. but just by not by going with the electric resistance. And then even the next most efficient option, where they're running with a minimally compliant air source heat pump water heater, they were still 16% more efficient by going with the wastewater heat recovery heat pump. So that was a big driver there, because this allowed them to truly achieve that net zero, because they had so much less energy that they had to make up on the consumption side with solar panels on the roof. So this is really where a lot of developers will get caught up and say, well, net zero is not cost effective. And it's like, well, if you're using traditional air conditioning, heating, and those types of technologies, I would agree with you. It can get very cost ineffective, because the amount of solar that you're going to have to need to overcome that large energy use intensity on that site. So it's really imperative to run energy models, as well as really looking at what's deriving that load for that particular building, which in the case of multifamily, it's going to be your domestic hot water, because it's based on the occupancy and not based on the outdoor weather.
That's actually a really good point. Especially because Ryan knows I'm a huge solar guy. I've been doing this for 14 years, and he's the big geothermal guy. And he's right. Sometimes you get on a roof and you can stack solar panels for days, and a lot of times you can't, or it's so cost prohibitive to move everything, that you sort of use what you can on the roof for solar. And this is when other technologies like geothermal really come in for older buildings that maybe don't, like you said, they don't have the rooftop space, or there's shading issues or whatever. Um, this is sort of why I wanted you here today, because I think solar, like you always say, is always in the spotlight, but this is something that could be just as big or bigger. So
Absolutely. So, really what's going on in that building is, as that wastewater is leaving the building, there's a tank that captures that water, that wastewater. And as the building people get up in the morning, 6 o'clock, everybody starts showering. It's going to call for domestic hot water, and it's going to call for heat. So that's when we're going to pump wastewater into the heat pump water heater. And then that process of the heat pump of transferring the energy from wastewater from refrigerant to the water, that's what's going on inside. And then that's when you're going to get the domestic hot water out to the apartments. And then as that temperature degrades inside the water heater, a valve opens, the water is rejected back out to your sanitary wastewater, and the wastewater tank process starts all over again, where we refresh with warmer thermal energy. So it's a really good opportunity on your multifamily, hotel, senior living, those types of facilities, where instead of just having the wastewater, leave and throw all that thermal energy down the drain, this provides a building by building level to capture that energy and put it back to use. Another thing that in this post-COVID world that we're going to be seeing a lot is contract tracing. How are we going to be best doing that? So this, obviously, we know that COVID can be traced through wastewater. So what this does on a building by building level is it allows the facilities engineer of that building to use that wastewater in that wet well as a testing sample, then to determine if that building has the presence of COVID, or really any virus in that wastewater, because this wastewater has not gone out to municipal sewer yet. So it's not mixed with any other building quite yet. So it brings in that building by building level of, providing access to contract tracing and say, hey, we've got this dormitory, and guess what? We've got somebody that's got COVID. So, it opens up a whole nother level of, not only are we providing, energy efficient hot water and, air conditioning to buildings, but we're providing potential testing points of, locating, viruses down the line.
wow. So before you go on, I've never heard that. It makes total sense, because you've got the wastewater right there, for contact tracing and isolating a building down and telling people, that they could have it. I mean, that's amazing. That's the first time I've ever heard that. So that's a really cool takeaway. Especially, like you said, post-COVID world almost makes you realize how dirty the world kind of was. People didn't wash their hands. People weren't sanitizing tables and doorknobs correctly. So, I mean, this is really, really cool. I mean, every hospital, every nursing home should have this. I mean, this is amazing.
So on to some of the larger scale opportunities that have done in wastewater heat recovery. So one was a municipal water headquarters in the eastern U.S. It was a 150,000 square foot Class A office building. It achieved LEED NC Platinum, as well as several other AIA awards. And the most interesting fact about it is actually before COVID, it had one of the most rented out wedding venues on its rooftop. Is just, I guess, spectacular views of the area it's in. And so on top of this municipal water headquarters was a rentable wedding venue that was, doing really, really well.
You would, I definitely wouldn't have thought of that venue for my wedding.
I definitely wouldn't have, and their reasoning for it was actually pretty neat, and I think you'll enjoy this, Shelby. Is they didn't want the additional costs of going this route to be pushed back on the ratepayers,
Wow.
so the revenue from the wedding venue is going to cover the incremental costs.
Eco weddings. If you're a wedding planner, that's awesome.
So in that building, the wastewater heat recovery system consisted of a filtration unit and a heat exchanger, and then a heat pump HVAC system that was providing that heating and cooling and domestic hot water for the building. So using this instead of traditional sources, they didn't have to have any boilers that were burning natural gas on site. They didn't have to have any evaporative fluid coolers that would be evaporating millions of gallons of potable water, requiring lots of chemical water treatment, requiring lots of maintenance. When I came into this world selling Evapco cooling towers, and learned very quickly that cooling towers, they work really well at scrubbing the air of everything. So they really become, contaminated with all kinds of different things very quickly. So in the commercial world of HVAC, anytime you can reduce or eliminate cooling towers and their usage is definitely really seen as a positive to most facility engineers I've ever spoken with. And then also, mechanical room wise, you're also going to see a smaller footprint than you would see in most mechanical rooms with traditional equipment. So the HVAC equipment actually used in the building was one of them was known as a heat recovery chiller. So you'll see there it's got 6 different pipes. One set of pipes is for what is known as the source, which would be in this case the wastewater energy recovery system. One is the hot water loop, and then the other is the chilled water loop. So those hot water and chilled water loops are supplying what's next to it, which is it's known as a chilled beam. So don't let the name fool you. It says chilled, but it can also provide heating. So your ventilation air from the unit on the far right there is called an outside air processing unit. So the ventilation air, this is big in the COVID world. Your outside ventilation air is pre-processed by that unit, taken through MERV 13 filtration, and then entered into the space at a predetermined rate set by the American Society of Heating, Refrigerating, Air Conditioning Engineers. So that rate then, so the outside air comes in through that unit, and then that air is either cooled or heated using the chilled water, hot water plant that you'll see there on your left.
So, every school needs this like today. Man, I mean, this will make a lot of parents feel more comfortable, whether you want to send your kids back or not, or even if like here in El Paso, we don't even have the option, I don't think right now, because of our extremely high COVID cases and lack of management by city leadership. So, I mean, but this is really cool that these things are sort of on the shelf and can be plug and play pretty quickly. I have a feeling there's going to be a lot of retrofits in schools and nursing homes and office buildings pretty soon. This is very cool stuff.
Thank you. I know in the HVAC world, the things I've been seeing, particularly in indoor spaces, is ventilation, filtration, and then the addition of some sort of, bipolar ionization combined with UV technology can really be the ultimate test to get everything out of there. But some combination of those things are, truly what I believe is going to be needed in the HVAC world for schools to, mitigate the risks aligned with what's going on right now.
Yeah, it's almost like you might have to go to school to get clean air, because I know in some places in El Paso, you're better off at school than in your home by a diesel bus stop or by the border where all the 18-wheelers are backed up and just polluting those neighborhoods. I mean, yeah, sorry to interrupt you. This is just super, super cool, not only for air quality, but for all the COVID. This speaker series is focused on sustainability during a pandemic. So yeah, this is all I feel like your industry is going to be put in the spotlight here very quickly,
It
more so than it has been.
definitely has been. That's for sure. And it, and it rightfully should. The ventilation standards and things like that need to be adhered to. And, these technologies are definitely out there. And so, but not to get too sidetracked on indoor air quality, as important as it is now. So these systems did not change versus for all that. So it was a heat pump HVAC system, no matter which route they were going. They were just changing what was going to be providing the hot or the warm source and of heat or the heat rejection to that heat recovery chiller. So that's where they had either boiler towers or a ground source system or the wastewater heat recovery system. So they weighed all three of those options out. With the boiler tower, you've got your cooling tower that's rejecting heat during the summertime. Boilers are injecting heat during the wintertime. It does have the lowest first installed cost. But one of the drawbacks to it is the increased utility costs and potential high maintenance costs associated with it because of the cooling tower and boiler maintenance. And again, kind of going back to the rooftop venue, they would lose the rooftop space to the boiler room and cooling tower room on the top. So when they went to the ground coupled option, instead of having the cooling tower and boilers, you've got the underground heat exchanger that's rejecting and injecting the heat. There they were going to be incurring some very high first costs just associated with the amount of drilling that would be required. They did, you would see lower utility costs, way lower maintenance costs. You would have no fresh water consumption, and you would preserve your space. But it was that first cost for a municipal utility that they could not get over. So what that did is the wastewater heat recovery system really gave them the best of both worlds. It was about a 17% cost premium over the water source system, and still provided the same low utility costs and low maintenance costs and freshwater consumption preservation that you got from the ground coupled system as well. So when they, we're really looking at that life cycle analysis, again, it was 17% more than the water source, but in your operating expenses, it was a 72% reduction in water source. So when we're talking operating expenses, we're not just talking utility. That's your maintenance and your upkeep and, everything that goes into operating that piece of equipment. So this is where they really got that sense of the wastewater heat recovery system was going to provide the best payback for them. And they were actually calculating a rough 5-year simple payback for the entire system. And at the same time, we're able to eliminate 1,350 metric tons annually for GHG emissions on site.
Yeah, that again, the 5-year payback and throwing in an ROI percentage in there for builders, I think that's what's going to get them. Especially if you pay 17% more, the savings is far more than that 17%. So, yeah, if anyone is a builder and you're listening, especially in El Paso where water is a sacred resource, yeah, this is all very relevant.
And then one of the other big things that I stress with anybody, so I'm over on the West Coast, so I cover California, Alaska, Oregon, Washington, multiple different areas. So I'm dealing with multiple different electric utilities. So, but each one of them has some sort of custom incentive program or peak kilowatt demand reduction program or some sort of thing like that you'll definitely want to take a look at when doing this life cycle analysis, because that can dramatically reduce first costs right out of the gate when you bring in those utility incentives.
Yeah, our electric utility, if anyone is on from El Paso Electric, I think what you said is what everyone hears is peak demand reduction, which means less need for additional power plants, especially dirty natural gas power plants. So yeah, that's peak demand reduction is huge. And again, water.
So one of the other things that really came out of that system is, so your ground source systems or water source heat pump systems, they operate on a temperature range. And that range of temperatures is directly associated with the efficiency of that equipment. So the less you can have that range vary, and especially the more you can decrease its relative low and high peaks, the more energy efficient that system's going to be. So that was one thing that really got out of the system there on site too, was versus the ground where they had a 40-degree delta between its peak and its low. There's a vast range of temperatures that system would be seeing. And then For the cooling tower boiler, it was a little bit less of a delta, and then for the wastewater heat recovery system, it was even less. So that by shrinking that band, their system becomes that much more energy efficient, and the exponential increase of efficiency just by raising your water temperature in the wintertime or decreasing your water temperature in the summertime, has dramatic effects on that electric consumption and peak electric demand as well. Another project in Denver, it will be the largest wastewater heat recovery system in North America, providing about 3,000 GPM total of wastewater flow. The total campus area is about 2.2 million square feet. And just from the wastewater flowing beneath it, about 90% of all heating, cooling, and hot water loads will be met. And that was just using a very small percentage of the wastewater flow. So you could get the sense that really just kind of dipping their toes in the water to see, how effective this could be. But then, as you can see there on the rooftops, there's about 11.4 megawatts total of solar PV array around the entire campus as well. So this was really taking net zero to totally new heights and showing that it doesn't have to just be building by building, and that it can actually be more cost effective when you do a campus or district style. So looking at your typical campuses, traditionally how they've done it is a building by building approach, where they'd have a heating and cooling system by each building, may have a cooling tower if it's water cooled. You've got a separate system creating air conditioning, and a separate system creating hot water, and a separate system creating heating. So it's very clunky, lots of moving parts, and truly, in my opinion, it's a Cro-Magnon way of looking at district energy systems. So what they were doing here is instead having what they call an ambient loop. So they say ambient because the water in that loop is roughly 75 to 85 degrees. So it's kind of an ambient neutral temperature. And that flows to each building on that campus. And then within each campus, there are water-cooled heat pumps that are providing hot water, chilled water, or that air conditioning heating for that building. So now it's an all-electrically powered heat pump. So they've got the PV array on top, powering the all-electric heat pump that's providing the air conditioning, hot water, and domestic hot water for the building. So you're no longer even having natural gas to the building. You can see that green line was completely eliminated. And that was one of the big goals of this campus, was to dramatically reduce natural gas consumption and actually eliminate the infrastructure where it could be. There were some areas for medical purposes and other things like that where they needed natural gas to be existing, but most of the areas, it was definitely not being used for heating or hot water production on the entire campus. Kind of get an idea of what they were building out total size wise. You've got all the different various buildings that connect into, there you can see at the bottom, the CUP is the central utility plant. So from there, the ambient water is distributed out to each building. And then again, each building connects to that, and it provides for heating and cooling for itself. And again, achieving that net zero at scale, they looked at the total power consumption over the annual basis, and we're looking at exactly how much solar they could do based on the Excel net metering rules. And as you can see, they were able to really get that net zero power consumption or a net zero possibility there with the amount of solar that they get on the rooftops.
Yeah. Wow, this is like a no-brainer if it's a new building construction. I know it's a little harder to retrofit, still worth it. But this is, I mean, any residential or commercial or like a retail strip, yeah, this is awesome.
And that's really what I kind of get into in the end is redefining the American suburb. There's lots of places where there's master plan communities still going up, large, very, very large, small, but the idea of community geothermal or community thermal loops is really not new. There's several places all around the United States that are already doing it. You've got Norton Commons in Kentucky with over 600 acres, Whisper Valley in Austin with over 700 acres, Serenbe in Georgia. They've all got these community geothermal loops, and they've really kind of changed the face of residential development and how it can be eco-friendly and net zero friendly right out of the gate. But these are all recent developments. Going back even as far as '97, there was the Fort Polk installation in Louisiana, had over 4,003 military units. And one of the unique things here is you can see the dramatic energy and peak load reductions, but because of the peak load and load factor, they were actually able to negotiate with the utility a better rate structure because of the reduced demand that this would be bringing in versus a traditional air source system. So in your warmer climates, this becomes a negotiating tool with, again, with your utility saying, hey, partner with us to build it this way, what we see is the right way, and we actually all achieve the same goals. We get the sustainability that we want. You guys get a summer peak load reduction, and your load factor improves. So it can really become powerful when you start talking about moving water through water and thermal energy through pipes, as opposed to having individual air conditioning systems, building by building, home by home. Um, so really, I think taking it a step further, the community geothermal is amazing, but it does require lots of bore fields and lots of drilling in the grounds. So what we're doing is replacing replacing gas pipes with water pipes. And all these communities, all these homes, there's going to be schools, there's going to be recreation centers, there's going to be all the residential dwellings, all the homes, all potentially multifamily, maybe some hotels. The point is there's going to be a lot of wastewater flow. So why not take that wastewater flow, take that energy and reuse it and distribute it, similar to the district energy system in Denver. And then you've got all your homes that are interconnecting with that district loop, all your schools that are interconnecting with the district loop, and all these different entities that are then interacting with that district loop, so that you're no longer having to drill all the boreholes as your primary heating and cooling, but your geoloop then can provide for your peak cooling and peak heating conditions. And then if it's in a super cold or super hot climate, you can throw on a boiler or a potential cooling tower just for those very, very hot summer days where you may not be able to have that thermal energy transfer from your wastewater or your geoloop conditions.
Wow.
So what are you getting out of that? Out of that district system, you're getting a lot of reliability. It's been proven that district energy systems, they provide a much more reliable source of heating and cooling and hot water to their buildings. You see them all over Phoenix. Here in Denver, there's a downtown district loop. A lot of downtowns already have these district loops in place. They just haven't been, this ambient single pipe style, but the reliability and resiliency and efficiency of them has been proven year over year. These ambient systems also then you're laying the groundwork for net zero. And again, these are all electric devices and machines that are connecting to it, so they can all be powered by solar, wind, battery. The local wastewater utility in areas where you're going to be taking a lot of heat from that wastewater, they actually get a benefit because they're removing that heat from the wastewater, which they're being penalized by the EPA right now for having too warm of effluent temperatures leaving the plant, and then obviously going into our river streams and
Really? Oh,
everything else.
that's an
So
extremely good point.
if
Wow.
you can find ways to remove that heat from the wastewater before it hits the plant, you can form these partnerships as we've done in Denver and King County to benefit that local wastewater utility. Obviously, we're going to be supporting local sustainability goals. We're reducing greenhouse gas emissions. We're reducing energy consumption. We're being powered by solar. All these things align with your local sustainability goals.
Brian,
More usable rooftop area.
I have a question. Would you say that a
Yep.
lot of people like yourself or developers, would you say they're almost always partnering with the water utility and on every single project from ground up?
For wastewater heat recovery systems, most definitely. Because there will be eventually some tie-in to the municipal wastewater utility, that having some involvement with them would be, I would say, considered absolutely crucial.
Great. Yeah, because we definitely want to, partner with El Paso Water Utility and make sure that there's open communication for any geothermal companies like yourself, just to get the conversation started in El Paso. I know it started a long time ago and it died out, so hopefully we can get that going again and put a spark behind it.
So going back to the, reducing the drilling requirements when we're using wastewater as the primary source and sink, that bore field becomes your secondary. So it's a whole lot less incremental for first costs, while achieving similar and or possibly better results from the entire the system itself. And one benefit to the owner of that loop field is it is also considered a hybrid geothermal system. So currently there are tax credits available for geothermal systems. For residential, it's very similar to solar. It's a 26%. I believe it's capped at 9,000. But there's a 26% federal tax credit available for residential geothermal systems currently. And then there are also commercial credits that is a 10% uncapped tax credit for the commercial systems on there. So when you hybridize a geothermal system, you're able to still capture those tax credits on that loop field while still including the cost of that wastewater heat recovery system, the piping, the controls, the pumps, all the different associated things that go into that system and make it work, all become part of that commercial tax credit, which can become very, very, very valuable to that the developer owner of the building.
Well, hey, on this slide before you move on, and I know you might be covering it, but just I'm a renewable solar guy, but I'm also a recruiter, and this visual, this photo, it almost seems like it's a really good transition as we move away from fossil fuels for anyone in the drilling industry and fracking to get out of that, and potentially they could take their drilling skills over to the geothermal side. Do you see that happening currently, or do you think that that's a route to transition, from dirty energy jobs to clean energy jobs?
100%. If you were to Google right now, geothermal oil and gas drillers, you would already see that that transition's happening, and people are already doing that, saying, "Hey, we've got the rigs, we've got the skills. All we need is some different accreditations and some new training, and we're ready to go." So it's definitely another avenue to transition away from your traditional oil and gas industry over to a clean industry while still doing the same thing that you've already known.
Nice.
Absolutely. So definitely, a very large job creation opportunity. One thing that has happened a lot on these community systems that it opens up is having third-party ownership of that of the energy center. So all the underground piping, the wastewater heat recovery system, the geothermal bore field, all that stuff is owned by a third-party entity. So what that does is it takes away the first costs from the low-income community that might be coming into this, or whatever's connecting into this energy center loop field. The first costs of going this energy efficient route are not borne by them. So that energy developer then takes on those first costs. They get to benefit from the tax credits. Again, going back to that Fort Polk example, they then as an entity have that potential to negotiate with that local utility on different rate structures for that microgrid, if you will, community. And then all the users that are connected to that are billed based on their usage of that thermal loop, which is very simple. There's energy meters that are already commercially available, and the site in front of your home would look really nothing similar than your gas or your water hookups that you would already see. So if somebody was not paying their bill per se, the owner of that thermal utility could come in very easily and basically shut off the water pipes to that building, and you would no longer have heating and cooling. And then again, everything is all electrically powered and compatible with solar, wind, and battery there on that site. So you can really quickly see how having a third-party entity come in and own the energy, asset, and then having entities hooked to that asset, and then they're all powered by electric, wind, and solar. You've got the potential for a microgrid in that area very, very quickly realized. These types of systems also, I think one of the big benefits is, particularly in the US, people like choice. They like the ability to be able to choose what they want to put in their home or their building. So by going with this type of condenser water system and then having each individual home or building or school or whatever interconnect with it, you leave that choice with the homeowner on what type of HVAC and heating system they want in their home. So if they're used to that forced draft furnace, then they can go with your traditional water to air heat pumps. If they're looking for something like radiant heating or cooling, water to water heat pumps can be done. If they like, the wall mounted mini split fan coils or the concealed look of VRF, they can go with a water source VRF system that provides the same exact benefits. Really, this would be big in your older historical buildings where they may not have the space to run ductwork or piping. They can be bringing this in as in a residential or a historical residential home, have this water source unit in the basement, and then have your concealed ducted units or wall mounted fan coils there in the spaces where they may not be able to drill into the historic site. Again, heat pump water heaters for your domestic hot water, and then your heat recovery chillers for, you know, your larger high-rise buildings that may be using hydronic heating cooling systems. It really leaves that choice with the building owner, so they're not restricted saying, hey, you've got to use this type of system if you connect to our loop. Because, you know, I think that would be a big hurdle to overcome. So this, you know, keeps that choice open and, you know, really allows people to, you know, go with what they want. And with that, I will say thank you, everyone. Really appreciate the time.
Nice. Thank you, Ryan. You know, if anyone does have any questions, we can sort of open it up, you know, one at a time. And we have Ryan on the phone. He, you know, he is from El Paso. He's a local who transplanted over to Colorado, and he is, you know, the geothermal expert that I always go to. So if you do have questions, now's your chance. If not, we can always, you know, you can email us at info@ecoelpaso.org, and we'll get all your questions over to Ryan, and he can interact with you, as well as his contact information is on the page. He was kind enough to even give you his cell phone number and his email address. So I highly recommend you take advantage of Ryan's expertise. If you want to bring geothermal, you know, projects to El Paso, please get with Ryan. Especially because he is a local El Pasoan. We'd like to always pull him back here when we can. But I will open it up. Any questions before we end the Zoom video today? Might have to come off of mute. All right. Well, I'll take that as a no at this current time. But again, you can email Ryan. You can email Eco El Paso. This is a part of our 13th annual conference here for Eco El Paso. We are an all-volunteer nonprofit, so any donations you'd like to make are greatly appreciated. We give 100% of our donations back to the community in form of our projects, which include giving solar to nonprofits who own their buildings, our Million Trees El Paso program, which will be starting our first project here coming the first week of November. And then we've also got National Drive Electric Week. We started the chapter for the Rio Grande Electric Auto Association. And we have lots of events throughout the year. And then we always have our annual conference. But this year is virtual. It's free to the public. We are posting all these videos. So if you weren't able to make it today, the first 3 videos are already out there. I will be uploading this one later today to our website, to Facebook, and to all of the events pages as well. So don't worry if you or your friends didn't get to make the whole thing. We will have the whole recording on there. And like I said, please reach out to Ryan. Ryan, thank you. Your expertise is awesome. We love to have it. We're so thankful you always get back to El Paso. And we will hopefully see you in person at the next year's conference.
Awesome. Thank you so much for the opportunity, Shelby.
Thanks, everyone. Have a great afternoon. Take care.